Yesterday we were having a look at motherboards, which are basically just big old complicated circuits. Circuits are the electrical connections that we built in class using a battery and some wires and a function like a light or a fan or whatever the computer wants to be able to do. And I wonder if anybody can remember from yesterday how a computer is like a brain. Actually, no, I won't ask you that straight away because we've just jumped back in. So, P.
The electric can send the message and be faster than our brain.
Good girl, yeah. So computer and the brain both use electrical signals to send messages, and the computer is faster, and they both transfer information. Sorry, this is a bit rushed. I've got to make up some time now. Computer, they send electrical signals, they transfer information, but we're going to have a look at how. Could everybody read out this information, please?
Computers transfer information in bits and bytes and binary code. Electrical
And binary code. Electrical signals to send messages, transfer information.
Good job. Okay, so the same way we talked before about what units do we measure distance in, guys? Give me any unit that we measure distance in. What's on your ruler?
Centimeter.
Centimeters, good. And then what if we have something bigger than centimeters?
Meter. Inch.
Meters, yeah? Or kilometers, good. So when we're talking about like our millimeters, the smallest part would be the bits, and then our centimeters would be the bytes. That's all it means. And binary code is what it makes up. I've got a video for you in a moment. We're just going to watch this for 2, maybe 3 minutes, kind of give you an introduction into binary code, and it's much more simple than you think it is. So in binary code, if it's 1, that means it's on, and if it's 0, that means it's off. Okay, the same way that 10 millimeters is 1 centimeter. And when we had a look at our Super Marios, there was one that was really boxy, and that was an 8-bit Mario. And then we had one that had more detail, and that was a 64-bit Mario. So it's just how many units of processing power go into it. Okay, we're not going to do all of it because it's not necessary, and I just want you guys to have a basic idea of it, and then I'll go over it again in the PowerPoint. What would the fifth light bulb be?
16.
16, good. And what would the next light bulb be? What's 2 times 16?
32.
32. And what would the next one be?
64.
64.
Yeah, okay, so it goes on and on and on and on and on, because binary code can have many, 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 many digits in it, but we're not going to worry about too many of those. Now, the next bit is kind of like a puzzle. This is where it kind of becomes like a number puzzle, and it's why I'm not going into too much detail for it. Let's say you've got each of these are cards, and you want to make up different numbers. You can only use each value once, and if you don't use it, you've got to put a 0 in it. Basically, I've got no 1s, no 2s, no 4s, and no 8s. How do you think you'd show number 3?
1 and 2.
So this says 0, 0, 1, 0. And that means 2 because we've got 1, 2. We've got no 1s, we've got no 4s, and we've got no 8.
0, 0, 1, 1.
Yeah, 0, 0, 1, 1. I have one of the 2 values and one of the 1 value makes 3. Okay, that's enough of the video for now. But guys, how would you show the number 5?
0,
how would you
1,
make 5?
1.
Yeah, so you have 1, 4 and 1, 1. So this would be, like Philip said, 0, 1, 0, 1. Okay, that's it. Now, they've got different values for letters and things like that as well, but we're not going to worry about that because we don't need to. So thank you very much for the video. Now, Nana, what is a bit?
Is binary and digit.
Good. Bit is short for binary, digit. Good. What 2 forms does a bit have? It can either be on or
Off.
On or off. Good job. Okay, thank you, Nana. And it controls that with electrical signals. So a bit is the smallest piece of information in communication. For example, if we were talking about distance, it would be equivalent to 1 millimeter. If we're talking about time, it would be the same as 1 millisecond. But for computing, we've got 1 bit. Tyann, so if we've got a string of 8 bits, can you remember what that's called?
A byte.
A byte. Good job. Okay. A byte, short for binary term, which just means a string of 8 of them. Now, using light bulbs to represent Bell, what does this bit of binary code represent? What number?
This binary code represents number 1.
Number 1. Good job. Do we have any 4 values in this binary code?
No.
No, because there's a 0. Do we have any 2 values?
No.
No, because there's a 0. Do we have any 1 values?
Yes.
Yes, because there's a 1. Good. So that's the mathsy version. We have 0 8s, 0 4s, 0 2s, and 1 1. I mean, what does this bit of binary code, what number does this represent?
11.
Now it looks like 11, it's representing the values for each of them. So I mean, we've got 0 8, 0 4s. Do we have any 2s?
Yes.
Yeah, we've got 1 2.
So 21.
Nearly. I know it's confusing, but if we've got 1, I'll show you. There. We've got 1 2 value, and we've got 1 1 value. So what does that add up to?
3.
3. If we've got 1 times 2 and 1 times 3, don't worry, guys. I promise we're only going to do this today. I mean, gang, how will I figure out what number this is? I've got 1 times 8 plus
1 times 4 plus 1 times 2 plus times 1.
Good job. Okay, should we try and figure out what that is? So we've got 8 plus 4, which is
12.
12. 12 plus 2,
14.
14. And 14 plus 1,
15.
15. Good. There you go. Yeah. Okay. Right. This is what a byte looks like. Okay. It's got 8 bits in it. Each one is double the last one. This is all to do with the electrical signals that get sent around the motherboard. You can only use each light bulb or bit once per turn. Any light bulbs you don't use must have a 0. How can you make the following numbers? I want to see if can anybody make the number 12 just using these numbers? You can only use each number once. P?
We turn on the number 4 and number 8.
Good. Number 4 and number 8. And if we're not turning on the others, what do we put in?
0.
Put in the light bulbs?
0.
0. Good job. 0. So if we want to make the number 12, then we can use the cards or the light bulbs or the values. 8 plus 4. Nice. Okay. Next number is 40. Have a look. How can we make 40 from these cards? Ice cream.
We will take 32 and 8.
Good boy. Yes. So 32 and 8. And then ice cream. What do I put in the other light bulbs if I'm not using them?
0.
0. Oh, look at you guys read a binary code. I had to go off and learn this like over the break. Oh, such beautiful handwriting. Well done, teacher. Good job. Okay. Good man, ice cream. Do one more. What about the number 43? So have a look at what we use. We use 32 and 8. That gets you to 40 already. Okay, I know you know. Tyann, how can I make 43? So to make 40, ice cream turned on 32 and 8. And that gets us to 40 already. And now we need 3 more.
Turn on the 2 and turn on the 1.
Ah, perfect. Okay, and then what do we put in the spaces and the values we're not using?
0.
0. Oh, and guys, just, yeah, you can read binary code. 00101011 is 43. There we go. Okay, that's it. That's all I needed you guys to do today. We've gone over the time. I'll let you go. And then tomorrow, we're just going to quickly rehash how does a computer process information. Can you all turn your microphones on? What type of signals does a computer use to transfer information? Good. Electrical signals. Good job. Okay, time's up. I'll let you go.
Bye-bye.
Everybody,
Bye-bye.
bye 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 bye.